We'll be talking about the role of policies and what the policies talk about specifically. And to talk about them, we have Mr. Bhaskar Natarajan with us today. So Mr. Natarajan has over 25 years of experience in the field of sustainable development. He has worked extensively with organizations as well as international funding organizations and private agencies. He is currently a senior policy advisor at Alliance for Energy Efficient Economy, AEEE, which is based in New Delhi. He has, prior to this, also served as the Director of Energy Efficiency and Clean Energy at the Institute for Sustainable Communities. His earlier work experience includes working as a Deputy Chief of Party with USAID PACE-T Technical Assistance Program. He was also the Managing Director for Sequest Capital. He was a country leader at IRG's SSA, South Asia, and also heading the Organization for Energy Management Center at the Ministry of Power, which was managing the country's national energy programs. So apart from this, he has also written 2 books on renewable energy, which talk about the policy issues impacting the renewable energy adoption in India. So with that being said, I would now like to invite Mr. Bhaskar Natarajan to run us through through his presentation and tell us a little more about the EV market landscape in India. Over to you, Bhaskar sir.
Good morning to everyone. Thank you, Dhruv, for the introduction. I'm now going to share my screen.
It's visible, sir.
Yeah, it's visible. I'm just trying to navigate up or down. Or how that up or down. That is
Sir, you will find one navigation button in the left hand side corner, below side.
Left hand side corner.
At the bottom.
Yeah,
bottom, sir.
Now I think it's moving, but I'm back. So yes, okay, I saw it now. Perfect. Excellent. All right. Thank you so much again to GreenTree for this opportunity, to AEEE for sharing some information on the EV market landscape in India. The Alliance for an Energy Efficient Economy, as some of you may be aware, is an industry platform set up in 2008, working with various stakeholders, including the government, the private sector, civil society organizations, state, center, and city level organizations to further the cause of energy efficiency. E-mobility is an important part of India's strategy to limit the damage due to various economic activities on the environment. And today the session, as Dhruv said, is all about the EV thing. Before I go into the actual presentation, I just wanted to make a couple of general remarks. One is that almost all of us who are here know something about EV. We know that EVs are a new technology. We know that EVs are upcoming. It will probably take over the whole transport sector in the next 10, 15, 20 years. We also know something about the problems, charging problems. Where do we charge? How do we charge? How long will it take? What will happen if I get stranded in the middle of the road, and so on and so forth. This whole session is to give you a better understanding and appreciation of the complexities that exist in this evolving policy landscape, and how all of us need to work together to solve these problems, so that you and I, as citizens of India, as consumers using e-mobility devices, have a very smooth move in living our daily lives. The challenges are many, and I'm sure all of you will have several questions. Happy to discuss this towards the end of the presentation. Let me move forward. Yes, we will start with a brief on a policy landscape in India. I did want to mention that GreenTree has put together this exhaustive presentation. There is a lot of information in this presentation. And I think if I were to read through everything and start explaining each one of the items here, it will probably take a much longer time. I'm going to highlight some of the major points that each of the slides are making. And I'm sure all of you will have a copy of the presentation so that you can read through it at your convenience. And therefore, let me start by saying that the policy landscape in India on e-mobility is evolving. It started way back in 2013 when the national mission was announced. And then the government announced plans to transform India into an e-vehicle economy by 2030. The government announced the FAME 1 and FAME 2 programs with a huge outlay of over 10,000 crores. Progress is going on in these programs slowly but steadily. In order to encourage India to manufacture e-vehicles and everything related to e-vehicles, not just e-vehicles, e-components, e-batteries, e-charging, all the rest of it. There is a production-linked incentive scheme that has been set up, and manufacturers are free to apply for claiming under the scheme. There is a target set of about 40% of public fleets to become electric and 80% of 2- and 3-wheelers to become electric. Challenges are large, and we will see some of these as we go along. The mobility mission plan was basically to promote the usage of hybrid EV propulsion-based vehicle technology. There was a roadmap that was prepared, and a new manufacturing policy was also outlined, projecting EVs to contribute to 25% of the national GDP by 2022. The production-linked incentive scheme is to ensure that we are able to make in India everything that we need. We don't want to be importing everything and then assemble them in India, as we are doing in a number of cases. This has various components in terms of manufacturing in the battery segment, in terms of investments for the manufacturing of e-vehicles, and these are expected to result in a massive investment of about 45,000 crores, and the net savings are huge, as you can see. And there are a number of Indian companies, including the Tatas and the others, Reliance and Adanis, who have announced great plans for entering the e-vehicle space in terms of battery and other systems manufacturing. The FAME India program, FAME 1 and FAME 2, are essentially launched to incentivize production and promotion of e-vehicles, including hybrid vehicles. As I mentioned earlier, the overall fund allocation is around 10,000 crores. They plan to roll out incentives for 2-, 3-, and 4-wheelers based on the size of the battery. This is a brief breakup of the total funds that are available for various elements under the FAME program, and different stakeholders, whether you are setting up charging infrastructure, whether you are manufacturing batteries, or whether you're manufacturing e-vehicles, there are incentives available and government support that is available. Government keeps announcing revisions to the FAME program depending on the offtake and depending on the technologies that are developing very, very rapidly across the globe. For two-wheelers, they increased the demand incentive to 15,000 from 10,000 per kilowatt hour. The state-owned Energy Efficiency Services Limited, which is a Government of India company for energy efficiency, is expected to aggregate the demand for 300,000 e-three-wheelers. Cities are expected to convert their bus fleets into electric buses, and therefore the whole issue is to go into the total cost of ownership, because today the e-vehicle may be expensive, car will be expensive. Car costs anywhere from 10 to 12 to 15 lakhs or even 30 lakhs. But if you see over the life of the car that it will run probably 2 lakh kilometers, if you see the total cost of ownership and divide it for a per kilometer, you will see that e-vehicles are significantly better off than the conventional petrol and diesel vehicles that we are using today. And more on this you will learn as we go along. The government, as usual, has certain conditions to be met if you want to avail of the incentives. You have to be registered with the government. These have to be manufactured in the country, and there must be some amount of localization. You can't just import everything and put them together and fix the nuts and bolts. And there is a certain warranty that is also prescribed, because this being in the initial stage, the government wants to ensure that manufacturers provide services to the consumers for an initial period of 3 years. This may be extended from time based on the manufacturer's own experience. This gives you a very brief on the output as far as the FAME 2 performance is concerned. As you can see on the right side, that there is a huge amount of reduction in CO2. There is over 1 crore of liters of petrol that has been saved under the FAME programs. The numbers are still small, but they are running excellently with the support of the manufacturers. And I believe that the FAME 2 program will probably get extended further. Let us look at states. Over a dozen states have set up their own policies for e-mobility. The Andhra Pradesh government has been one of the early governments to look at e-vehicle policy in 2016 and commissioned it into a full-fledged movement in 2018. There are a number of important components in the policy. What are the outcomes of the policy? They expect manufacturing, they expect production capability, they expect certain research and development to happen, they expect product development to happen. Also, the state government is making a push to ensure that educational institutions are involved through the policies for research in e-mobility, whether it is batteries, whether it is drive components, whether it is anything else. They want the institutions in the state to become very proactive. In terms of infrastructural applications, there are a number of things that are being talked about. These will be deployed at the city level. These will be taken up for energy management. Environment monitoring will be done to ensure that the benefits of e-vehicles are achieved and there will be efficiency in operation. These are some of the key elements of the state EV policy. It expects huge employment potential. As you can see, 60,000 people are likely to be employed. Electric bus fleets, almost 10,000 by 2029. In terms of manufacturing, they are expecting that the state will have manufacturing of e-vehicles over the next 5 years, and there will be a number of slow and fast charging stations that will be installed by various stakeholders. In terms of industrial development, the policy expects EV parks to be set up along the lines of the solar parks that have been set up and the other industrial parks that have been set up. There is a financial assistance that is promised, and there is subsidy also available for charging stations, swapping stations, and other such activities. In terms of EV charging infrastructure in Andhra Pradesh, there are both private and public organizations that are in mobilization of the new charging infrastructure. There are large private companies like Tata Power, ABB, and others who are involved in this effort. There is expectation that R&D will be taken up by educational institutions and government agencies. The Indian Navy has agreed on mobilization of electric fuel-based technologies within their own establishments. And there will be some benefits in the income tax and registration on e-vehicle purchase. Sorry. There is a number of incentives that are available. These are all available as far as EV adoption in the state is concerned. I will not go into describing each one of these subsidies, but you can see that the subsidies are quite substantial. The state is expecting to reimburse GST, and EV has been exempted from a number of registration and tax requirements. Moving ahead, MOUs have been signed by the AP government with a number of private enterprises to ensure that the infrastructure is mobilized as far as the policy is concerned. I don't think we need to look at each one of them. They're all established names as far as the energy sector is concerned. Number of charging installations have already been set up. This is to make sure that there are sufficient charging stations mobilized at government offices as per the EV policy. And a number of these subdivisions have already got the charging infrastructure that is in place. This gives you a list of some of the ongoing projects. The DISCOM is going ahead with charging stations and swapping stations. And of course, the fact is that solar power for electric vehicle charging stations is a very, very great idea to ensure that we are using the sun to make sure we are using the charging facilities. And of course, the EV charging stations are being set up at national highways and state highways. The NRED CAP will look at the overall project implementation. And there are a number of other initiatives that are ongoing. EV policy cannot be implemented without multiple stakeholders. There are several government corporations that are involved, as you can see here. And these corporations and city corporations will provide much needed policy breakout, facilitate charging, facilitate various activities under the e-mobility program, because they are part of the stakeholders to implement the e-policy program. Let's look at the EV market landscape. Let's look at the global picture. Globally, e-mobility has been in the picture for about 10 years now. There are reports that over 10 million electric cars have been sold by the end of 2020, out of which almost 30% were sold in 2020. Some countries have rapidly accelerated the pace of e-mobility. And large manufacturers, whether it is Toyota, Tatas, or anyone, they're all getting into e-mobility and e-manufacturing at the global level, and global companies are setting up factories in India as well. These are some of the countries that have gone ahead with announcing targets to switch to clean mobility. As you can see, about 10 countries will do it by 2030, another 10 countries by 2040, and so on. These are countries where there is 100% target that has been established for switching over to clean mobility. In the Indian market, the expectations are that the vehicles will grow very rapidly, 20%, 30%, 40%, there are a number of numbers that are being mentioned. And the schemes and incentives such as the FAME scheme are important in launching the e-mobility program. 13 states have approved or notified dedicated EV policies. And the expectation is that by 2025, the EV market in India will be about $7 billion US. In terms of market opportunities for e-vehicles, the numbers planned are very large. We are talking of million numbers in terms of sales by 2027. Battery demand is expected to hit 50 gigawatt hours, out of which 40 plus gigawatt hours will be from lithium-ion batteries. And if you see these numbers, these are really, really large. And today we are probably at less than 5% of what these numbers are. We really have a long way to go. And I'm sure with the participation of all the stakeholders, we will move towards these targets. This is something that tells you that two-wheelers are the major buyers today. Over 1.5 lakhs two-wheelers are bought in India. These are some big names and some small names. The last few weeks, you would have seen advertisements by several small unheard of companies, Ola, Ether, and several others that are now planning to come up with two-wheelers for the Indian market. This is something that talks of projections as far as e-vehicles are concerned. Projections by 2030 are massive. As you can see, 30%, 40%, 60%. The rapid growth is going to happen in the next 10 years. And we all need to be prepared, depending on our category of stakeholders, to support this move to e-vehicles in India. This gives you a very brief information in terms of the charging scenario in India. What are the tariffs that are there in all the states in India? Which are the states that have declared EV tariffs for charging? And there are still some states that are yet to declare tariffs. There are fleet preferences for EV charging and battery swapping. And while the swapping options are around 50%, the logistics of three-wheelers still is depending on plug-in charging options. There are different types of charging service providers. It is within the office premises, on public roads, in terms of public parking spaces, and captive charging for demand for cabs and other equipments. And this is something that the governments are working towards to provide as many charging stations as possible so that you as the customer will not be inconvenienced. This is just to give you a very brief snapshot of what AEEE has done in the e-mobility framework. We have looked at India's bus transport charging. We have looked at four-wheeler charging. We have also looked at what are the tariffs for e-vehicles. We have looked at vehicle grid integration. And we have also looked at the whole issue of green vehicle rate. How do electric vehicles compare with normal two-wheelers and three-wheelers? Whenever you have time, please feel free to go through the AEEE website, which is aeee.in. Last part, key components of an EV value chain. We are looking at the main first box, which is the fellow who manufactures the vehicle. And there are different components, the battery, the traction motor, the electronics, and other components. The sales, after which you have the after sales servicing, repairing, resale, and various other activities. You need electricity for running the vehicles. So you need electricity for charging stations. Charging stations have to be installed. The charging stations have to then be open for public to come and do the charging. Of course, you will charge a small tariff. And lastly, we are talking of predictive maintenance, fleet management, charging infrastructure, and all this, considering today everything is available on the mobile. The Internet of Things will tell you if your battery is down, where is the nearest charging station? What is the tariff? How long will it take for you to reach there? And so on and so forth. The key infrastructure elements in the e-mobility systems are basically the operation control center. This involves the charging infrastructure, the grid connecting the charging points, and of course, links for data recording, metering, billing, etc. Also, the charging station itself. There are 4 types of charging stations that are available: residential charging, AC charging stations, which are slow charging stations, and of course, battery swapping. The two-wheelers, in the evening, you can just take the battery up to your house, plug it into the charger, and by tomorrow morning, the battery is ready for you to get on to your daily work. Grid connectivity solutions is very important because each charger, the connecting load is fairly high as far as these are concerned. If you're going to have a bank of 5 or 10 chargers, the grid needs to be ready as far as charging is concerned with the local transformer capacity and all other accesses for the grid system, which is extremely important. So the DISCOM becomes a key player in the e-mobility framework. This again gives you a lot of detail on who are the various actors, manufacturers, fleet operators, infrastructure operators, utilities, government agencies, and you can see all the very well-known names of Adani, ESL, and so on. But there are also some small names that you and I have not heard about. Number of them are international companies. They're all looking to get a small piece of the Indian e-mobility market. Let me stop here and happy to take questions or discuss anything that the group wishes to talk. Thank you once again.
Thank you, Ms. Bhaskar, for running us through this session. Very informative indeed. And we have a couple of questions. So the first question is from Mr. Sunil Mathur. So I think the question is regarding how do you look at scenario for EV versus hydrogen? So essentially it is about lithium ion versus hydrogen. How do the two fuel sources compare?
Very interesting question. See, this hydrogen while it has always been there as a part of the alternate solutions, it is probably only in the last 5-6 years that it has become a serious contender. And at the moment, the focus is on industries to use hydrogen, which is in large quantities. And second, my thinking is that hydrogen, if we move to the transport sector, will probably be first used for large scale transport, like we used CNG for trucks, for instance, right? Buses. In my view, that is where the first priority will be. And I am not sure that, at least in the next 10 years, I'm sure technology keeps changing, but we are going to see much of a development as far as two-wheelers or three-wheelers is concerned. I don't know. I mean, things can change, but my thinking is that first, the large volume users will shift, which will be trains, which will be buses, which will be trucks. And then is the question of the smaller e-mobility, like your two-wheeler, three-wheeler, because the trucks, buses run for thousands of kilometers every month. That is where you will have maximum savings. Scooters run for probably less than 100 kilometers, 30, 40 kilometers per day. The cars, probably the private cars run for 40 to 80, maximum 100 kilometers per day. I'm not talking of taxis which run for 200 kilometers a day. So this is where hydrogen is a promising fuel, and I believe it will happen in this priority. Thank you.
Okay. No, so we have another question, which is actually with regards to the charging solutions, but if you would like to take it up, it is basically, so Mr. Suresh Kumar is asking, what is the difference between a DC fast charger and a level 2 charger?
I'm going to request my colleague Chandana is also here. I'm going to request her to answer this question. Chandana, would you please come in?
Hi, everyone. Definitely, Bhaskar, sir. My name is
thank
Chandana. Yeah, I work in AEEE Power Utility and Electric Mobility vertical. So to give you an example, based on the power levels, actually globally, there are some classifications on charging technology. So this was initially done in US, and in US level 1 was classified on the basis of how easily you could get a connection. So for level 1, it was considered as you could get a connection at your home. That was considered as level 1 of charging. And the easiest way to charge those vehicles was using the chargers on board the vehicle themselves. Hence, this was commonly associated with AC charging. And the next level of charging is what could be possible at a commercial end. So you are looking at faster connection. This could not be possible using the chargers that are on board in the vehicles themselves. Hence, this charging was primarily done using the charging equipment which is outside the vehicle, which constitute the part of the DC charging in itself. So hence, for the level 2 of charging was commonly associated with DC charging. That being said, what I'm trying to say is that if the onboard charging capacity of the vehicle is higher, it is possible to do level 2 charging from AC also. But commonly, as it is not a great practice, because this has implications on the vehicle efficiency in itself, and also from safety and other perspective of having a high power charger on board, typically the common design practice that is followed in this case to keep the charger outside and supply the DC to the vehicle in itself. So even though level 2 charging is commonly associated with DC charging, we cannot say that all level 2 charging is DC charging, but definitely the first level of DC charging that we would see, like which is commonly at the 50 kilowatt level, for if you are using a CCS kind of a charging, or at what could be at a 15 kilowatt connection level or so. If we are looking at the charging that is done under Bharat DC 001, they could all be as level 2 charging. But if you look at a global example, though we don't have these vehicles in India, especially if I were to look at some cars like Tesla, which have very high batteries, and even buses and other cases, there could be higher levels of charging. There could be level 3, level 4, level 5, and so on and so forth, which is at very high power level, which is also called as ultra fast charging. I hope I have explained the answer.
Thank you, Ms. Chandana. I think that answers the question. It was a pretty elaborate response. In fact, we have a couple of follow-up questions on that as well. So one of the questions that has come is a separate cable required for fast charging, DC charging versus a normal charging? And what kind of protections are envisaged in a charger plug owing to the flammability of the batteries?
All right. Can I take up this question again, Bhaskar sir, with your permission?
Yeah,
all
please.
Right. Yes. So when we think about a DC fast charging, and especially if I'm looking at a higher power level, the cable carrying capacity, as you can see, becomes a factor, because the voltage that I have to supply to this battery pretty much depends on the battery voltage, which is typically around 300 plus volts if I'm looking at like a high voltage car. So in this case, the current is going to be very high. If I were to take the case of, the first generation electric cars in India, which is based on the REVA model, then their battery voltage was even lower. Their battery voltages was less than 110 volts. That being said, what I'm trying to emphasize here is when I'm doing faster charging, I have to supply a huge amount of current, and hence the typical cable that you're going to use for it, thermal management of the cable becomes very high. So when we are looking at very high power charging, the cable might need better cooling capabilities, including what could be liquid cooling. As you can see, definitely this makes the charging in itself expensive. This is all related to the plug-in charging aspect. But if I were to look at cases like buses and so, since we are electrical engineers, quite pretty much appreciate this, because we have been using this pantograph kind of systems to supply power. Especially this can be done at a DC or AC angle, but these kind of systems are also popular if you want an alternate for plug-in charging. From the safety perspective, definitely safety becomes critically important during charging. So every charging watch will have two inbuilt functions. How I can explain it is, be it an AC or a DC charging, one of the first functions that you will have is called a proximity sensor, which will ensure that the charging will only happen in case there is a connection between the car and the EVSC, that is the EV charger, and this connection is maintained well throughout. At a point where, imagine there is a hitch on the cable was pulled a little and this connection is disrupted, the charging automatically stops. That's the first level of protection there that starts. And then to talk about the protection, this is included in something else called as the modes of charging, which also talks about different level of protection that is there, including isolation between the vehicle and AVSC itself. That's a larger conversation, but I would recommend that this is part of some of the research we have done at AEEE. We would be happy to share the resources that might be able to answer this question.
Thank you, Chandana, for sharing the elaborate response. So there is one question related to the batteries, which talks about the battery recycling, and the user asks whether battery recycling will pose a pollution threat to the society, and what are the processes involved for recycling the batteries.
I would only say that I'm not too familiar in terms of the processes involved, but I believe that the government has a very important role to play, just as it has played in the automobile battery segment. There are recycling rules that are in place. Almost every seller of the battery takes back the old battery, beyond which you and I really don't know what happens to those batteries. But there are a detailed set of rules available for this, and I believe for the EVs as well. The government will have to bring in some very strong regulation to ensure that recycling does not damage the environment. Chandna, if you are aware of any specifics regarding the technicals of recycling, you may wish to share.
Thanks, Professor. I think there are multiple methods. What we believe is for recycling, there are some agencies who are getting into the battery recycling of lithium-ion batteries in itself, but that is actually at the mobile phone battery level right now. There are different methods. There is a lot of research going on as well, and there are some companies getting into the business. As Bhaskar sir already said, I also believe going ahead, not just recycling, but reuse of the vehicle batteries as the grid level storage will also be a factor that is critical for India. I'm going to stop here, Bhaskar sir.
Dhruv, we just wanted to add here.
Sure, sir. Please go ahead.
Yeah, so currently the government of India is in the process of coming out with a dedicated policy for battery disposal for from the e-vehicle industry. Right now, whatever the battery disposal guideline is there from the e-waste point of view, so that is more from the electronic waste and which includes the battery. And these e-mobility sector battery disposal and recycling is expected to take the course in the next, I would say 4 to 5, but very soon, within a year or two, there will be policies going to be put in place by the government of India. Right now, the biggest plant which is there for the battery disposal is by the Tata in Maharashtra. So I just thought I will let the audience know about these things.
Thank you.
Sure, sir. Thank you for sharing that information, Pradeep sir. So with that, I believe we have come to the end of session 2, and I would like to thank Bhaskar sir and Chandana ji for sharing the valuable information and insights with regards to the EV market in India and how it is evolving, especially from a policy perspective. I would also like to thank AEEE as an organization to be able to participate in this program run by UKPAC, and sharing this information with all the participants today for the creation of relevant awareness and the information dissemination in the ecosystem.
Thank you so much.
Thank you, sir. So moving on, let's now look at our third session for the day.